All right, hello class. This is our conceptual design review for the sports injury prevention team regarding ACL tears. My name is Julian Delgado.
My name is Andrew Vaccarello.
My name is Brandon Orozco.
Carlos Molina.
And Frankie Martinez.
The main goal of our group is to prevent ACL tears in athletes. Most of the sports injuries are ACL related, which occur during non-contact incidences. The knee has 6 degrees of freedom, which lead to different ways of causing strain on the ACL. The ACL is the main stabilizer of the knee joint, and it prevents the tibia from sliding in front of the femur, preventing knee joint from hyperextension. This provides angular stability and rotational stability. It has 6 degrees of freedom, as shown in the picture to the right. It has extension, flexion, external rotation, or internal rotation, varus, and valgus.
So this is the injury mechanism of the ACL. Basically, movements that would cause that are known to cause ACL injuries. So sudden changes in direction, sudden stops, because when you stop, all the way in force go to your quads, therefore falling on top of your knee. Jumping and landing wrong, or unpredictable rotation, and this is because usually your ankle and knee are not aligned. And then next are the types of tears in the ACL. So it starts off with normal, right? Regular ACL, no tear. A grade 1 sprain, ligament slightly stretched, still able to provide stability. Grade 2 sprain, small tear in ligament, unable to provide full stability. And then grade 3 sprain, ligament is in 2 pieces, full loss of knee stability. In grade 1, treatment is non-surgical. So this would include bracing, physical therapy, and our gradual progression. And our goal is to prevent grade 1, grade 2, and grade 3, but especially prevent it from going from surgical treatment.
So of course with this project and this designs, there are constraints that we have to put on. We don't want to put users in danger by having them test these movements and possibly tearing their ACLs. So most of our constraints come from athletes making unpredictable movements according to the sport they play, and also having unavoidable contact with other players. The environment also plays a big factor, such as the weather and ground surface, because that cannot be controlled. And if the ground is wet and things like that, it could also cause for sudden movements that the user isn't ready for. So one of our performance requirements is that our design does not stop the normal range of motion. So the maximum knee flexion for males is 137.7 degrees and females 141.9 degrees. The ACL strain increases with a 15 Newton meter valgus or varus moment with knee flexion angles less than 40 degrees.
And our second performance requirement is that the product should be able to minimize knee rotation. So the knee could rotate external and internal. So if the knee has external rotation with valgus moment, it increases the ACL tensile force, especially when it's at a 15-degree angle of knee flexion. And also a combination of knee internal rotation and quadriceps forces, it could cause a strain on the ACL. And the ACL experiences a strain at knee external rotation, whether it's at 12 degrees or more. And then our third performance requirement is to prevent the knee from reaching maximum levels of stress. So our product should be able to prevent the ACL from reaching a maximum load of 1,818 newtons.
Now moving on to features, we thought that the product should be able to adjust to the majority of population. And in order to reach the adjustability, the product needs to accommodate for users between the 5th percentile female to the 95th percentile male. So as you can see on the right-hand side, we have some dimensions that should be considered when designing a concept. For example, thigh circumference and knee circumference, as well as calf circumference. Okay, as far as aesthetics, we thought that the material should be comfortable So when the user is to be moving, it should be abrasions-free and should not create more friction than the latex-free neoprene material, which is a material that is frequently used in the knee sleeves.
So this is my first concept design. It is a non-Newtonian fluid pants, and it is basically a pair of elastic pants, which are comprised of suppression short-like material that contain a thin layer of non-Newtonian fluid followed by a layer of compressed air. The elastic pants material allows the muscles in the lower half of the body to stay compacted together, preventing harmful motions caused by unsafe direction changes or sudden unexpected movements while allowing for easy mobility for active users. As seen in the pictures below, I used the elastic materials on the darker outlines where the air has a thicker layer than the hexagonal pattern shaped non-Newtonian fluid layer. And to the right picture is my prototype, which is just a homemade non-Newtonian fluid mixture in a baggie inside of another baggie filled with air. The compressed air act as an activated airbag, allowing to repel any blunt forces on the area impacted, as shown as the picture to the left, where I put my hand onto my prototype and the air was able to repel the force of my hand, not touching the non-Newtonian fluid layer. And the non-Newtonian fluid portion allows to act as a secondary protection for concentrated forces caused by impact that may get through the first layer, as shown in the picture to the right, where I put my finger onto the prototype and it would barely touch the non-Newtonian fluid layer, but was not able to penetrate it. The non-Newtonian fluid layer would be in a hexagonal shaped pattern, which basically holds it in place. Here are some of the pros and cons of my project. It would be, since it would be comprising a pants-like function, it would be sleek looking, works very well for active users, easy to wear, and meets the durability requirement by allowing the bandwidth of force applied on the knee before tearing to be minimized, evenly distributed through the knee, all throughout the legs. And some cons would be that it's difficult to repair if damaged, as if the air pockets popped or if the non-Newtonian fluid started leaking. The price of non-Newtonian fluid can be costly when bought in high quantities, and there's no current way to make the device machine wash friendly.
Okay, so now moving on to concept number 2. It is a phone application with a smart sleeve. So the phone application by itself would be split into 2 sections, one for recommendations and another one for conditioning. So on the left-hand side right here, we have an example of the recommendations, which would be used as a in-game. So these are recommendations that would be used when you're doing the activity. And so in order to make the suggestions, you have to input things like activity, your foot alignment, ground surface, and the weather you're in. And the reasoning for these suggestions is that it has been known that if you have the proper shoes or knee gear, that can reduce the risk of having an ACL injury. So now moving on to the right-hand side, which is conditioning. It's something you do before the activity, and it would just be videos of exercises that you will do to prepare you for a high-risk movement. Okay, now talking about the smart sleeve itself, the goal will be to improve current ACL prevention programs by exchanging the human supervision to programming assistance. And as mentioned earlier, the app will have 2 sections, one for recommended outerwear and another one for conditioning help. The purpose of the smart sleeve would be to record data of the user's knee movement and to assure they are doing the exercises correctly. So some of the examples of things the knee sleeve will record are the steps of the user and knee flexion. So the way the program will work will be that it would increase intensity based on the progress noticed by the device with the intention to properly strengthen the muscles around the knee, specifically the quadriceps. And some areas that the program will focus on are on improving agility for quick turns and landing skills. So right here on the right-hand side, we have some example. We have a prototype of the smart sleeve, and the smart sleeve itself would have characteristics of comfort and mobility. The sensors would be used to track the motion of the knee's movement, and in the center around the knee, on the sides of the knee, we would have the control unit, which would be used to record and collect data, and then send the info to the app. Okay, so now pros and cons for this design would be, so in terms of pros, we have that it strengthens the actual muscles of the user. The app is available for people without the sleeve for recommendations only, and it is comfortable. Now, moving on to cons, the sleeve is designed for in-game use. Cost is going to be higher than your average sleeve, and the electronics will add an extra weight compared to your average sleeve. And also, an issue might be that the duration of the battery of the sleeve might not last long enough as people would want to. Okay, so these are some questions I have in mind. So the first one is, what kind of sensors would be most accurate in determining the movement of the user's knee? And secondly, how long of a battery duration would be ideal?
For the third prototype, it's an improvement to the knee brace. So a new improvement is adding panels to the side of the knee. So the picture shows that the panels would cover a portion of the knee, but not all of it. And then these panels will move further inward towards the knee if the knee rotates either external or internal. For example, if the knee rotates outward, the panel on the left should move further inward to add more support to the knee and protect it. Also, the panel would have a mechanism within it to add resistance so the knee won't rotate further out or inward. So overall, the purpose of the panels is to add support to the knee and add resistance when the knee decides to go inward or outward rotation. And some pros and cons to the concept is that for pros, it reduces rotational movement. So it would limit the knee rotation, whether it's inward or outward. It would add more support to the knee. And then, because it is a knee brace and knee braces already exist, it will come in a variety of sizes to fit the majority. And then also the material would be used for pre-existing knee braces, so the knee brace would be comfortable. And as for cons, the panels can be possibly bothersome if not constructed well. And then because where the panel would be going in such a small place, it probably wouldn't be ideal to have one or two mechanisms within there. And then also adding more to a knee brace will just increase the cost. And some questions for this concept is, what mechanism would be preferable to create resistance for the knee when there's such limited space? And the second question is, what specifically would trigger the panels to move further inward when the knee rotates too far?
So for concept 4, the idea is to have rods going up the outside and inside of your thighs, and then straps going along your leg. These bands would stop the leg from overextending and also stop the knee from over-rotating. So the bands would be connected to the rods on the inside and the outside, and they would retract into the rods and then come out when the leg is extended. This would act it's kind of like a seatbelt, but for your legs, I guess, because it stops it when it shouldn't be extending too much. The pros for this is it stops the leg from extending and the knee from over rotating. It's easy to put on and take off, and it's durable enough to withstand contact from others. The cons is it could hinder more movement than necessary. It could stop your leg from having its regular extension. It might not be the most comfortable device with the rods going up the inside and outside of your leg, and it also might be bulky with the rods. One question I had was, how can this product become less bulky but still maintain the strength needed to stop the knee from rotating?
So concept 5 is a spring shock absorber. These panels with springs, ideally on top and the bottom, will be attached to the side of a sleeve. One panel will be on top of the knee, which is the quads, and the other one below the knee. The spring is used as a shock absorber to reduce the amount of force. Specifically, compression springs are used to absorb forces by squeezing together, but there's also torsion springs, which reduce rotation, so it all depends on the movement. The spring will absorb force when extended or compressed. This is due to the spring wanting to return to its normal position when stretched or compressed. The spring will help the knee in instances of jumping and landing or overextending. This is because when jumping or landing, you instinctively bend your knees. So when you land and you bend your knees, the spring will stretch, therefore wanting to bring them back together and lessen the force when you land. Some pros and cons. So pros would be will absorb forces that would damage the knee, resulting in ACL tear. This is just reiterating on the jumping and landing concept. It would also prevent overextension, or in other words, hyperextension, prevent the need to reach maximum stress levels, and can withstand loads with the correct springs. Some cons would be most likely not as comfortable as alternatives, will limit some mobility in the knee due to not letting you fully extend, and not as stable due to only being on the side of the knees. So some questions for this concept would be, how could the product be more comfortable? Is there a way the ACL could still tear? When taking material into consideration, what would be ideal? Lastly, this is the evaluation table, basically a summary of our pros and cons, showing the strengths and weaknesses of each prototype. Then our reference page, and that's it. Thank you.